Okay, can you guys see my screen?
Yes.
Awesome. Okay, I think I have the wrong screen share. Let me change that. Okay, can you see my slides?
Yes, we can see data engineering slides.
Okay, how does that? Okay, just give me a second here. Let me stop sharing. Share screen. Okay, is that better?
Yes.
Yes, looks okay.
Okay, great. So today's topic is data engineering. And, this is a very important topic, something I've been wanting to cover since a long time. So last time, if you remember, I took a session on storage, databases. Those were the major topics. And, while the foundations for that is very important, I think data engineering is the soul of data science, essentially. Because before you become data scientists, you have to be able to reach a stage where you have the data, right? Without data, there is no data science. And machine learning and artificial intelligence, all of that is built on top of a very core foundation. So what you will see that most of the organizations today, their focus is to automate their data pipeline, especially bigger organizations, right? Bigger organizations have a lot of lines of businesses. Their data is in a lot of silos. And there are many departments who want access to this data. There are many departments producing this data, right? There are many avenues from where data is coming. So how do you handle all this, right? And make the data ready for the data scientists to take and run with it, right? So that's what we are going to see today. I will be mentioning a lot of AWS services. I'll be giving a very brief description of what they are. So this won't be a typical presentation where we will get into the small finer details like we do for any of the AWS certifications. This will be like a high level overview, but and just because we will be covering so many services. But I would recommend that once you go back from this session, I'll forward you the slides, go through each of the services, read through the frequently asked questions on the AWS documentation site. And that is very important for you to be able to understand what the services actually mean, right? So what you're seeing on the screen now, what I'm sharing is kind of a data pipeline from end to end, right? From beginning to end. We are going to dive deeper into each section here. So don't be overwhelmed when you see this. You don't need to understand everything right now. But I just wanted to point out a few things here. Okay, so if you notice on the left side, we have something called data ingestion, right? So before we actually think about storing data, we need to understand what are all the places from where data is coming, and what are the various ways we can what are the various AWS services we can use to ingest all this data into a common location, right? Last time we read about S3. We will in the further slides, we will learn more about how S3 acts as a very good data lake. We will also see what a data lake means. But for now, think of it as a central repository where all the data from various places comes and sits, right? And data ingestion are basically different services which help this data to come to S3. Okay, so here you can see that we have third-party data, something called AWS Data Exchange. So this third-party data can be anything like location data, or whenever you use like a credit card with e-commerce websites, or if some websites are tracking data based on your location, things like that. So there are third parties who sell this data, and this data is used to complement any existing data sources you have. So you can have data coming from there. and then we have SaaS platforms like, Salesforce. Your employees must be using things like Salesforce, and they must be feeding data in there. So all that data is present on your on-premise servers, which you want to move to cloud as well. That can come. Then we have something called streaming data. So streaming data is essentially, think of it as live data, right? So for example, any company which uses IoT devices, right, or beacons, or any e-commerce website where millions of users are scrolling through different products and clicking on things, all that is live streaming data. And all that data needs to be stored somewhere so that in future you can do some analysis on that, right? So all that data needs to come to S3. And then finally, we have some operational data. So operational data can be data which is being produced by any like lines of businesses, right? So things like sales data or financial data, if you're ordering something on a website, or all that data, like the order IDs and things like that, all that data is stored in databases like relational data or NoSQL databases, things like that. All that data also can come on cloud and sit in a data lake. Okay, is that part clear? Any questions on the data ingestion? Awesome. So the next step is storage and processing. Okay, this we are just going to look briefly on a very high level. All the data which we just ingested sits in an S3 bucket, right? And that is the golden data, which means that we don't want to modify the data sitting in that S3. We want to keep it like a golden image, and so that we can always go back and get the data in its original form, right? And in the storage and processing section, so it's mainly processing. We use various AWS services to kind of understand what kind of data exists in those S3 buckets or the data lake, and then do some ETL, right? ETL means extract, transform, and load. It means that you cannot, most of the times, you cannot use the data in its raw format. So you want to take it, do some transformations, right? So add like some additional columns, complement that data, deduplicate, like if there are any duplicate values, remove them. So there can be a number of ways in which you can transform that data. So you do all that. And in machine learning in future, you're going to learn like what normalization of data means, how data needs to be in a particular format for the machine learning models for them to be able to understand the data, right? So all that processing takes place here. And whenever you transform a data, you have to make sure that you move the transform data, you are saving it in another S3 bucket, because you don't want to change the original golden image. Okay, so we saw what storage and processing means. And then we have something called cataloging, governance, and search, right? What cataloging means is, in an S3 bucket, when all types of data are coming, right, they can be in different varieties of format. They can be structured data, they can be unstructured data. We don't know what's happening. All the producers of data are just dumping their data in a data lake, but we need a way to be able to understand what this data means. So cataloging helps with that. There are certain AWS services like Glue. We are going to be looking at Glue in future. But what Glue does is, it's like a crawler. It crawls through your data lake. It basically looks at each and every file where data is present. It understands whether it's structured, unstructured, what kind of schema does it follow, right? Does it have any columns in it? What kind of data is in those columns? What type of data is it? Is it a string? Is it an integer value? Things like that, So Glue crawlers have the capability to understand what kind of data is present in a data lake. And what they do is, you can schedule a Glue crawler, every 2 or 3 hours. It will go inside the S3 bucket. It will understand what new data has been added, what are the updates that have been made on the existing data, and it makes a catalog. The catalog is essentially like a list of all the different types of tables or data which exists in the data lake, and keeps it ready for other services to be able to refer to that catalog. Okay, and then finally we have the consumers here. Once the data is in a place where you can take it and run with it, that's where the consumers come in. So we will see that there are like different consumers. SageMaker is of interest to everyone, right? Because you're going to be future data scientists. So you can see that out of this whole picture, SageMaker is just only a part of it, right? You have to do all this. You have to set up this whole data pipeline for you to be able to use SageMaker and run a machine learning model on that data, right? And then SageMaker is only for machine learning models. You may just want to do like analysis, or get some target data. So you can use Amazon Redshift for that. Redshift is like a data warehouse, and you can run like analytics processing kind of stuff on Redshift, where essentially you are running SQL queries to understand what kind of data is present and come up with some summary statistics, right? And then Athena and QuickSight are some other services. We are going to dive deeper into those in future, okay? And then finally, overlaying or underlying all that is security and monitoring, right? So you want to make sure, some of this can be very sensitive stuff, and you don't want people to be able, some certain people to be able to accessing this data, and it's not only because of security, but it's also because of regulations. Many organizations like the financial sector or e-commerce sector or any sector who is dealing with personal information, for them, they have strict regulations against putting access controls. And that's where some of those AWS services come in, like identity and access management, encrypting data using key management service, things like that. So this is very essential when you set up a data analytics pipeline on AWS. Okay, so I will be touching a lot of AWS services. Doesn't mean that companies who are running these data pipelines on premises don't do this. The underlying concepts remain the same. But as companies start moving towards cloud, just because it's very easy to scale, we went through all that stuff in our previous sessions, the advantages of cloud. But for all those reasons, many companies are now moving their data pipelines to the cloud. And AWS is like a primary cloud service provider where most of the organizations move their stuff. So we will be looking at these AWS services. All right. Any questions still there? Awesome. So I added this slide, for you to be able to understand what are the different types of data which we get, right? And there are, as you can see, that there are many dimensions to it. Here you can see, so on the left side, you can see the data structure, right? Whether it is structured data or unstructured data. And that makes a lot of difference, because you have to be able to decide where to store any kind of data that is coming in, right? And then on the lower side, you can see like what's the frequency with which you will be using that data, right? So like latency and how much data are you storing. So if you look at some of the services here, right, on the right side, you have the archival data. The cost of storing this data is very less, very less frequently accessed. Typically, you don't do any analytics processing, or you don't use that data for any machine learning models, things like that. You're just archiving it, So that kind of thing you just store in something like Amazon Glacier. And in the center, and the biggest circle of them all, right, it covers various aspects. That's the data lake, which we will be talking about. So S3. And as we saw before, S3 doesn't care about what kind of data you're putting into it. It's just like a central repository. You can dump everything there. And that's why here you can see that the cost ranges depending on what S3 storage class you use. We spoke about that in our previous session. And then you can see that it doesn't really care about the data structure. So right here. And then on the left side, you can see that all of these data storage are kind of purpose built, right? And most of the times you will see that S3 acts as the underlying data storage. So for example, if you want to use Amazon Redshift, right, you can see that you can only use it for highly structured data. It doesn't really help if you have something like JSON files or documents. You can't really store them in Amazon Redshift. So there are certain limitations when you come to purpose-built data storage. And that's one of the primary reasons that most organizations, what they do is they initially dump all their data into a data lake, and then depending on what the use case is, they will catalog it, and then they will use purpose built services like Redshift or Elasticache or Elasticsearch, DynamoDB, etc., to pick up data from S3 and then run some analysis on it. All right. So I'm going to be sending these slides.
Sorry to interrupt.
Sure.
What is it meant by highly structured data?
So highly structured data, as in, last time we saw relational databases, right? So RDBM. So if it's something like an Oracle database, inside that you will see that there are different tables, right? And all those tables are related to each other. So for example, if there is a customer, there's a table for customer, and there's a table for all the orders which a customer is facing. So you won't store all of that in just one table. They're going to be separate tables, but they are going to be related. So if you want to see what are all the orders which a customer has placed, you just do like a SQL query, and it will join those two tables to give you the results, right? So in this case, it's very structured data. Does that make it clear?
I got it. And Amazon S3, does it use NoSQL database, or does it use SQL and NoSQL SQL both?
Sure. So last time we spoke about different kinds of storages, right? Like block storage, file storage, and object storage, right? So when you look at these databases, any kind of relational database, it typically uses block storage. S3 is not like that. S3 is a object storage. What object storage means is that it doesn't really care about what kind of data you're storing on it. So you can dump unstructured data like JSON files or documents in S3, or you can also dump, structured data within S3, like CSV files. You can just dump it there, and S3 doesn't care about it.
Thank you.
Sure. Awesome. So let's move along. Yeah.
Sid, I just have one little question. In the previous slide, by hot data, did you mean that transactional data, more transactional data in the hot side?
That's right. That's exactly right. So if you look at Elasticache, right, that's an in-memory database. And usually in-memory databases, if you look on the top, right, the cost is very high to store something in memory databases. So typically organizations, they won't store everything in Elasticache, right, because it becomes very expensive. So it's a thin line between how much you want to spend versus how much value you want to get out of that.
Got it. Thank you.
Sure. Awesome. So let's move along. So there are different layers in an analytics workload, right? So, and this is what we saw earlier. So we are going to dive deeper into those. So you have the data ingestion layer, data access and security layer, catalog and search layer like Glue, which we saw, the central storage layer, which is the data lake or S3. We have the processing and analytics layer. So this is where things like MapReduce or, SageMaker, things like that will come. And then we finally have the user access or interface layer. Okay. So moving along, we'll start with the data ingestion layer. So this is responsible for ingesting data into the central storage for analytics, such as a data lake. And then it's comprised of services that aid in consuming data sets in batch and real-time streaming models from external sources. So some of the external sources can be things like, website click streams, database event streams, financial transactions. Social media feeds is a big thing. So many organizations, if they have something like a Twitter handle, they want to understand customer sentiments. And to do that, they want to do like a live streaming of any social media feed that is coming in, right? Then we have IT logs, which are coming from the different applications, right? Sometimes you have the IoT telemetry data. If you have like beacons installed in your factory or in your, in stores, all that data. And then finally, we have the on-premise data sources. So relational databases, things like that. Sometimes you don't want to keep it there. You want to take it and put it in a data lake so that all the organizations, all the departments across your organization can use it. Okay, so let's look at some of the services which are used in the data ingestion layer, right? So the first one is Amazon Kinesis. Kinesis is a family of services for ingesting real-time data, and it provides capabilities to securely load and analyze streaming data, and then stream this data to S3. Now you might ask, why do we need Kinesis, right? So sometimes the rate at which data is coming in, your databases can't handle it, right? So if you want to store some things in relational databases, let's say, or if you want to store something in S3, so sometimes the speed with which this data comes, or the volume of data which is coming in, it's very difficult to handle all that data. There are certain limits sometimes on making. So for S3, there can be limits on making the total number of HTTP calls, things like that. So Kinesis kind of helps with that. It takes data, it keeps it for a certain period of time, and then on the other side there will be consumers who can take the data and use it. Okay, so Kinesis is used for streaming data. Now, again, I won't be getting into too many details just because of the number of things we are going to cover, but highly recommend to go back and look at these services and try to understand what they actually do. There are many videos available online. We also provide Amazon managed streaming for Apache Kafka. Apache Kafka is not, it's similar to Kinesis, but it's a open source version. Many organizations who are not on AWS yet, they use Apache Kafka for streaming services. And once they move to AWS, if they don't want to use Kinesis, this is another option for them. Then we have the AWS database migration service, right? So typically organizations who are just migrating their databases to cloud, they have huge databases which they're currently using, right? And to be able to take advantage of having a database on cloud, they need to do a migration, right? And this migration can sometimes be very difficult because let's say it's an e-commerce website, right? And if you're migrating the data, they don't want any downtime because that will be a loss of revenue for them. So there is something called a database migration service which AWS provides. In this case, everything remains fully operational while you're migrating your database in the backend, right? And then we have Snowball. This was a homework from the previous session I took. Sometimes, there are petabytes of data sitting in a data center on premise and you want to move it to cloud, right? Imagine, right, if you just uploading a file in your email takes a lot of time sometimes, because of the internet bandwidth. And if a company wants to move all their existing data to cloud, those are petabytes, exabytes of data. You can't do it over the public internet. And Snowball essentially helps with that. Snowball is nothing but like a huge hard drive. Think of it as a huge hard drive, which AWS will ship to your organization. You can transfer all your data to this hard drive and ship it back to AWS. And AWS is going to put everything back into the cloud. That way you don't have to travel through the public internet to transfer all your data, which can take multiple years for petabytes of data. Okay. And then we have AWS Direct Connect. Direct Connect acts on similar lines. So for example, if a company is connected to AWS, right? So for example, whenever on your laptop, you open your AWS console and you are uploading something, right? That goes over the public internet and that can sometimes be slow. What AWS Direct Connect does is that it creates a private network connection between an organization's data center and the AWS data center, right? So it's like a direct line through which all your network traffic can pass instead of traversing through the public internet. So organizations can sometimes set up Direct Connect to set up their pipeline as well. And then we have IoT Core. That's another huge topic, but IoT Core is nothing but a central place where you can organize all your Internet of Things devices and manage them. And then eventually we have data sync. So data sync, essentially it's like a data replicator. sometimes when users are creating data, let's say on their local laptops, right? And you don't want that data to be lost when, let's say, a laptop malfunctions or something. You want to be able to store everything on cloud. So data sync essentially helps you make that connection to cloud, where any file which is there on your local machine, or it doesn't necessarily have to be a file on your local machine. It can be something on your servers as well, on-premise servers. Data sync essentially replicates all that data into cloud. Okay, any questions on the data ingestion layer?
Hello, sir.
Yeah.
Yeah, in hybrid cloud, for
Mhm.
example, I have a data center, private data center.
Mhm.
If I want to copy the data from the private data center to the AWS cloud,
Right.
what should I use? AWS data sync or direct connect?
So there are multiple ways to do it, right? Direct connect is not only for sending, files or anything. It's also for the connection you're making. So if you're using any services on AWS, direct connect will make sure that the latency is reduced when you're accessing those services, right? Data sync can be used for replicating files, right? So not necessarily transferring. So yeah, data sync can be used for transferring files as well. And then there is AWS storage gateway, so there are different types of gateways like S3 file gateway, things like that. So you should look into that depending on what the particular use case is. All these different things can be used. I don't want to dive too deep into that, but that will be like a good homework for you to do.
Okay, sir. Thank you.
Okay. Yeah.
Oh, yes.
Awesome. So let's move to the data access and security layer. Many times people overlook this, but when you're building a analytics pipeline, you have to make sure that you are providing the necessary access controls. There should be an audit trail of who is accessing the data. For any audits which will be done, all the data, whether it's in resting or whether it's in transit, should be encrypted, right? Ideally, if it's sensitive, things like that. So we will look at just a few services. You already must be aware of the identity and access management IAM service. It's used to manage access to AWS services and resources securely. And here you can also create and manage things like users and groups, and use permissions to allow and deny their access to AWS resources. Okay. And then we have CloudTrail. CloudTrail is used to continuously monitor any activity which is related to data access from the different users or roles across your AWS infrastructure, right? So it will keep track of any kind of calls being made to your services. And then we have Amazon CloudWatch. CloudWatch is used for logs, so essentially monitoring any of your AWS services, right? So if you have something running on your EC2 instance, some database, you want to install CloudWatch on that, so that it's collecting all the logs from there. And in future, if something goes wrong, it becomes very easy to troubleshoot that. Okay. And then we have AWS Key Management Service and Cloud HSM. Okay. So if you don't know how data encryption happens, that is a topic which you should note down. Very important for security. You should be able to understand how encryption works. What do you mean by a key, right? Whenever you go on your Amazon account, you have to create a key and you have to encrypt your data with that key. How does that encryption work? So that is something which you should definitely take a look at. But key management service essentially you can create keys in a key management service. And you can use that to encrypt any data which is stored. So for example, in an S3 bucket, you can do that. And Cloud HSM, is nothing but it's like a hardware module, and it's exactly like key management service, but with Cloud HSM you can use your own keys which are brought in by your organization, and it can integrate with key management service to encrypt the data. Okay, again, these topics can become a little complicated sometimes if you don't exactly understand what it is. There are like many good videos available. I can help you with those as well after the session. Okay, any questions?
Just quickly, AWS key management system, is it like crypto, like encode data in a crypto format or something like that?
Correct. So it encrypts the data, and when you encrypt the data, right, there are like different algorithms which you can use, and key management service essentially generates a key. Anyone with that key, can encrypt the data, and like there are public keys can decrypt the data, private keys can encrypt the data. So you should look into that. But key management service essentially generates those keys which will encrypt the data, and then on periodic basis you want to rotate the keys, because if like a certain party gets access to the private key, they can decrypt the data, and you don't want that to happen. So key management service takes care of all that. It rotates the keys, it generates the keys, it deletes the keys, things like that. Okay,
Got it. Thank you.
awesome. Then we will get to the catalog and search layer and the storage layer. Okay, catalog, as I was talking about earlier, right, it basically manages the discovering and cataloging of the metadata pertaining your data assets, right? So any data which you store, there is a certain metadata associated with it. It can be anything like the column names, what are the sizes of things which are stored, what are the types of values which are stored in those column names, whether it's structured data, unstructured data, what kind of format the data is in. All these things are called the metadata, and AWS Glue essentially helps you understand what that metadata is, and then it also like provides you a user interface for you to go and look at the different data sets. Okay, it also provides search capabilities. So as your data sets grow in quantity, there will be scenarios where you want to, let's say, find a table based on a particular criteria, and that's very common when you're searching. So Glue also provides like an interface to do that. Okay. So you should look into this. Glue can also do ETL. There is something called Glue Data Brew, which is not mentioned here, but it can also, do transformations to your data when it's going through it. There are various ways to do an ETL process. This is just one of the ways, right? So depending on what your use case is, anything can be used. Okay. And then we have the Amazon Elasticsearch service. It's basically Elasticsearch is again, Elasticsearch is not developed by Amazon, but the Amazon Elasticsearch service is essentially a managed version of Elasticsearch. Okay, so you can create Elasticsearch clusters, and this kind of storage is usually used to do like search. It's very good for doing searches. So if you have like a lot of documents and you want to do like a search on those documents, this will be a good service to use. And then we have RDS and DynamoDB. I'm not going to dive deep there because we already had a session on both of those, but those are another two places where you can store things, right? And here I'm only talking about cataloging, right? So there are many services in AWS which actually use the Amazon DynamoDB in the backend, right? And in the backend, just to store these different types of metadata and things like that. Okay. And then finally, we have the central storage layer. As we know, as we have already discussed multiple times, S3 and EBS are the major ones. S3 again will be the data lake, and EBS is block storage. Block storage, think of it as, if you want to run a relational database, right, on your EC2 instance, EBS will be the block storage which we will use in the backend. Okay. Any questions here? Okay, great. All right, these are the final two things, and then we will dive deeper into the data lake. Okay, so we have the processing and analytics layer. This is responsible for providing tools and services for querying and processing. So things like cleansing the data, validating if the data is correct or not, transforming the data, enriching. Enriching means complementing it with additional data sources, and then finally normalizing the data. If you don't understand what normalizing means, as a data scientist, it's very important to know that. So note it down That is a whole another topic, but something you can look into. And then we will get into the various services which can be used for processing and analyzing data, right? So the first one is Amazon EMR. It's a managed service to easily run and scale Apache, things like Apache Spark, Hadoop, HBase, Presto, things like that. Again, Hadoop is a very big topic, right? So I can forward you some very good articles on Medium to understand what Hadoop does, what are all the tools which are used in that ecosystem. But essentially EMR deals with big data, right? It's a big, it uses a lot of big data frameworks to kind of analyze and process the data. And you will also, when you read through Hadoop ecosystem, you will see that it does like massively parallel processing to be able to process this data, and which makes it very fast. Okay. And then we have Amazon Redshift. So Redshift is a data warehousing solution, right? Typically, customers used to use the data warehousing solution to analyze data on the go, right? It's very good for analytical processing, and that's why it is used. But the only downside with Redshift is that it only uses structured data, right? And with the number of sources from where data is coming in, Redshift is also very bad at doing concurrent writes. What that means is that when there are multiple live sources of data coming in, it becomes very difficult to directly put them into Redshift because of two reasons. One is that Redshift database can become overwhelmed because of concurrent writes, and it won't be able to handle it. The other reason is that it can only handle structured data. So if any, like IoT stream data is coming in, which is unstructured, for you to be able to modify that and store it in Redshift, it takes some time to process that, and you can't do it on the go. So that's why everything is first put into a data lake, and depending on what your use case is, Redshift can then pull the data from S3, load it into its own database, and then you can do some analytics on it. All right. Then we have Amazon Athena. Athena is an interactive query service that makes it easy to analyze data directly in Amazon S3, right? If you have certain data in S3, you don't always have to pull it into Redshift, and which is a data warehouse, and use it. Athena essentially sits on top of S3, and it also takes help from Glue. If you remember, Glue has already crawled through S3. It has cataloged everything. And now Athena uses that catalog to understand what kind of data is present inside a particular table. And you can use your normal SQL queries, which are used to analyze that data. Okay. Then we have Amazon Neptune. Neptune is a graph database. Okay, graph database is another huge topic. Whenever you have data where there are a lot of relationships, right? So some of my customers at Amazon are in the retail sector, and in the retail sector, we have something called Customer 360, where we want to understand all the different types of data related to one particular customer, to understand what the customer likes, things like that, and to be able to address him or her, right? So Amazon Neptune is a graph database. Any data which has a lot of relations with each other and you need to store that, graph databases are great, and Neptune is a graph database provided by AWS. Okay. And then finally, we have SageMaker. You must have already heard it a million times, but it's a fully managed machine learning platform, that enables data scientists to quickly build, train, and deploy machine learning models. You can bring your own machine learning models, or you can use like existing ML models, which are already present in SageMaker, and take advantage of that. Okay. And then finally, we have the user access and interface layer. Here, things like Lambda, API Gateway, Cognito, things like that comes. Lambda is used many times for event-driven actions. So, like things. So, for example, if you, let's say, you are sailing on a cruise ship, and suddenly you update your age, you say that, okay, today's my birthday, my now I'm 21 years old, right? So essentially that's like an event which has happened, and Lambda can take that event and then update many systems which run in the back end and update those. Okay. API gateway is a API management service. It kind of like all the HTTP requests which you send to various services first go to API gateway and then go from there, right? So if you don't know what API management is, read about that. And then finally, Amazon Cognito. Cognito is essentially nothing but used for things like user sign up, sign in. It's used for federation. So just to make sure that any user accessing the data has the required access, Cognito makes sure that he or she has the required access and then allows them to access the data. Okay. Any questions here? Okay, great. So with that, we have looked at the various layers in a data analytics pipeline, right? I went through, like 20, 30 AWS services. Each service has a lot of depth to it. So make sure to go back and, go through each service and just like think in your mind if you understand what that service does. Okay. And then this is like the one big topic which I want to cover quickly today. And after this, we are going to stop. But data lake, right? We discussed the different AWS services. There are the producers of data, and then there are the consumers of data. But in the center sits the data lake, which is the data repository. Okay. And so what is a data lake, right? We already spoke about that. It doesn't care about the file format, structured, unstructured. It stores everything. It's object storage. So in S3, you don't want to analyze data directly in S3. Typically, you will pull the data out, you will transform it, and then you will use it. Okay. And then why do we need a data lake? There are multiple reasons. So the first one is it decouples storage from compute, right? So let's say on a Redshift instance, right? On a Redshift instance, it's a data warehouse where you are storing the data. And when you're writing a SQL query, it also analyzes, does an analysis, right? So you're doing both the things on the same system. And when a lot of people are doing that, the database can get overwhelmed, right? So data lake kind of helps you decouple those two things. Data lake acts as the storage where you are storing everything, and depending on what you need, you pull it into a warehouse and then you do an analysis on that, right? So you're kind of decoupling those two things. And then it also enables advanced analytics across all your data sources. So many times what happens is let's say your organization has its own database which it's using, and then let's say another line of business comes in and they also want access to that data, right? Many times they replicate that data and then they have to do some transformations to be able to make it helpful for their own use cases. Here essentially you have same data in two different places, right? You don't want that to happen. So typically organizations set up a data lake and ask everyone to dump the data lake there, any data they're producing there, and then depending on whoever needs it, they can take it from there, right? So it reduces complexity and reduces operational overhead as well. Operational overhead because now you don't need to worry about where different types of data are. Management becomes difficult. User access is a pain once that happens. So it reduces all that operational overhead. And then eventually, if you have an on-premise setup, scaling it becomes very difficult. Once you scale, things become very expensive. You have to make upgrades to your servers, things like that. So if you have a data lake on the cloud, especially S3, right? Amazon says S3 is infinite. It means that very rarely it happens that you'll want to go store something on S3 and there is no space. You can almost infinitely keep increasing your storage as per your data needs, right? So that's another advantage. So here you can see like the traditional analytics approach. Here you can see the different types of databases which an organization might have, right? So CRM like Salesforce, ERP database, like any data which is coming out of things like SAP, like the lines of businesses might have their own database, right? And then like just for transactional processing, you might have some data stores. all that data used to be dumped into a data warehouse, and then you used to use business intelligence tools, right? It can be things like QuickSight or Tableau. You can use those to analyze that data. That was a traditional approach. But we already know what are the disadvantages of only having a data warehouse, right? So data lakes basically extend this traditional approach. Now you have all these different additional new data sources, right? So initially storing data coming from social media, right? Or the IoT sensors used to be very difficult to store in a data warehouse. Now with the data lake, we don't care. Any kind of data source can put things here. We catalog it, right? And then we process it here. And then we use things like business intelligence and machine learning on top of it. All right. Any questions still there? Okay, awesome. So I've been speaking about the golden image a lot, right? Golden image is very important because, it's said that data has gravity. What that means is that, when there's a lot of data coming in, eventually it tries to go and settle in some place, right? And if you have disparate data sources, it becomes very difficult to find the data when you need it. So we need a single source of truth for that. Okay, and that's where data lake helps us. Okay, and then this point here is very important. It helps us quickly ingest data without needing to force it into a predefined schema. That becomes a huge problem if there's a predefined schema. Typically, that's the case in relational databases or data warehouses. There are a lot of limitations sometimes when some new data is generated. You need to first set up things in the backend before you can start storing things there. But with a data lake, you don't need to do that, right? Scaling, I just spoke about scaling. With S3, you don't need to worry about that. Here we are decoupling storage and compute, as we discussed before, right? And then it also provides a way to apply multiple analytics and processing frameworks to the same data, right? Because now everyone has access to the data. It's not in a particular format. Every time you want to analyze it, you take it, you apply whatever schema you want on it, you transform it in whatever you want, you analyze, run a machine learning model, get the results, dump that data. Next time it can be a new use case. You can again take the data, transform it in a different way, use a different machine learning model, right? So it gives you that flexibility. Okay. And then finally, this kind of shows you this different steps for building a data lake. We first set up the storage, right? So, like creating an S3 bucket and like the different hierarchies within an S3 bucket of how data will be stored. Then we move the data, right? We saw earlier how to move data using different things like, data sync or Snowball, or, setting up a direct connect, using storage gateways, things like that. Then we cleanse, prepped, and catalog the data. So using things like Glue, and like Glue Data Brew to do that. Sometimes Lambda can be used to transform the data as well. And then we configure security and compliance policies before you give access to anyone. And then finally, you make the data available for analytics, right? So once users have necessary access, once you have done all the cataloging, users can now look at S3, understand what are the different data available, and then they can do their own analytics. Okay, any questions? Awesome. So here, I'm not gonna, again, go into too much depth. This is essentially the whole ecosystem of how to build a data lake. S3 falls in the center, right? And then these are the various AWS services which we discussed, okay? And then here I just have a few screenshots, right? So sometimes screenshots helps you understand how things are happening, right? So here you can see Amazon Athena. So on the left side, you can see the different tables which are present in your S3, right? So these are essentially coming from Glue. Glue crawlers created this catalog, and this is the Athena interface. Here you can see that you can search, look at the different tables, look at all the columns which are present inside it. And here you can write your queries. And depending on what your query is, once you run it, the results will pop up here. Okay, that's how Athena looks like. This is the Amazon EMR MapReduce, right? So Hadoop looks like this. essentially, once you set up your cluster, you can use like Zeppelin notebooks to write your code. And depending on your data, you can get some summary statistics here, right? In the backend, data is being processed in your EMR cluster. Okay. Amazon QuickSight is used for visualizations. So if you have ever used something like Tableau or Power BI, this is like a data visualization tool. And here you can very quickly create things like pie charts and histograms and things like that. Okay. This is how the Glue data catalog looks like, similar to what we saw in Athena, but here you can't write queries. This is just a catalog. Okay. And then finally, we have the SageMaker for machine learning models, right? If you have used SageMaker, this is how typically the interface looks like. And then finally, you can load the data into downstream services, right? So we saw Redshift. Aurora is Amazon's version of a relational database. DynamoDB for NoSQL databases. Elasticsearch for if you have any use case for doing searches, things like that. And then finally, SageMaker for machine learning models. All right. I know it's like 11:04. I didn't want to drag this too much. I'm gonna share these slides, but any like final Q&A, any questions before we leave?
Yeah, in the Amazon Glue, we were looking at the catalog, and at the same time, can we just want to, if we want to make some SQL query, is that possible?
In Glue, you're saying?
Yeah.
So it's very easy, right? We saw Athena, and within Glue, you don't necessarily do SQL queries. You don't have that functionality. But once you have set up like a Glue job, which crawls through your S3 bucket, now you know what are all the tables present, and you can like very quickly use Athena to write your SQL queries. Okay.
Okay. Thank you.
Any other questions? Awesome. Thanks everyone for attending. I will forward the video recording on our Slack channel. Any of your friends who were not able to join today, ask them to attend, look at the session, or at least look at the slides. I think there's a lot of good content there. And keep learning. Okay, keep at it.
Will you provide the slides in Slack? Or
yes, yeah, I will do that. I will provide a link, a Google Drive link for you to be able to go through it. Okay.
And in previous slide, did you share the previous slides?
Yeah, so the Google Drive link, which I will share, will have all the previous slides as well. Okay.
Thank you.
Awesome. Thanks for spending time, guys. Take care, stay safe, and have a good night. Okay.
Thank you very much.
Yeah.
Thank you.
Bye.
Thank you very much, Sid.
Yeah, thanks.
For the others who want to actually, before we begin with Sid, so we were having discussion regarding our capstone project. So there was a question. So like our capstone project is to get the educational institutes data and to analyze the data where they are lacking specific problems. So like which subject are they lack on which region. So someone from our group, Farsim Bhai, he asked that we can have the data and we can have the analytics. So why do you need the machine learning thing? So would you like to talk?
If I sorry, if I may add just a bit. So my question was not that why do we need machine learning? Instead, I was thinking that should we focus on finding a solution, or should we focus on building the work with the machine learning model? I guess is it the solution do we focus on, and then the solution can be in very different formats like analytics, machine learning, or any other statistical research or any other types of format? Or do we want to focus on using machine learning model to find the solution? So where do we exactly focus on? Finding the solution or work with machine learning problem to find the solution?
Got it. Got it. So yeah, that's a great question, and again, there's no one way to do things, right? Sometimes you have a particular solution in mind, right? If you guys like discuss amongst your group, and if you say that, okay, this is the solution, what kind of data do we need, right? And then you go back, you get all the required data, and then you like do all the things like process it, clean it, things like that, and then you try to see whether your hypothesis was correct or not, right? Based on the data which you are getting. So that's one way to do it. But many times, you have a lot of different data sources and you want to be able to start somewhere, right? So you do like a exploratory analysis. So what exploratory analysis means is that you don't know what insights you are getting out of the data, right? So primarily, the whole field of business intelligence deals with this, right? They have the data. You create things like graphs, histograms, pie charts, depending on what makes sense for your use case. And you look at the trends, the historical trends, and then you see that, okay, in the last 10 years, this has been the trend. This is what we are seeing. We have the data to validate that trend. Now let's come up with a solution for how to solve that, right? So then comes the machine learning aspect. So first you do like an exploratory data analysis to find out what the different trends are there in your data. Then you discuss with yourselves on finding solutions, and then you decide, okay, how can we use like machine learning models to predict what the future trend is going to be, right? Or what are the future actions we can take to kind of change the trend. Does that answer the question?
Yes, I think I have to add with you. I think I can refer to the discussion we are having. I mean, Jaman sir were talking about the solution as an example, Khan Academy. When someone take a exam, when they do poor on the exam, so Khan Academy suggests to see the solution video, something like that. So integrating machine learning with our specific use case, we can integrate, we can do something like that. So the specific university or specific region who are lacking some kind of problem, we can have the personalized data using machine learning, and we can refer them similar like this kind of solution. I think that's the other way we can think about it, I think. Yeah,
definitely.
All right, thank you very much, everyone. And if Jaman sir is there, I don't know if he's here or not.
Yeah, he has like many things going together, so I don't know. Anyway, it was great to spend time with all of you. All right, I need to jump to another call, but I'll see you again next week. Okay.
Thank you very much. Thank you, everyone.
Bye, everyone.
Thank you, everyone. Thank you. Bye-bye.
Bye-bye.